Thank you, everyone. Welcome, and I'd like to especially welcome Dr. Calvin. Dr. Calvin is Professor Emeritus at the School of Medicine at the University of Washington, where he taught and spent a long time as an expert in the human brain. He's written 17 books, has written featured articles in multiple issues of Scientific American and numerous other professional journals. In the 1980s, Dr. Calvin, despite being a brain expert, became concerned about climate disruption, and especially that exhibited by extreme weather. So in 2008, after publishing some articles in 2008, he published his first book on weather and climate, Global Fever. And being a physician, you can understand why fever has sort of a health metaphor, and I think Dr. Calvin's work seems to have that health metaphor to it, which is wonderful. He co-founded the CO2 Foundation in 2018. Its purpose is to address issues of extreme weather and threats to agriculture, economy, public health, and security arising from extreme weather events, and to influence governmental policies and to be involved in large-scale emissions reduction. Dr. Calvin walks the walk. He is one of the core funders of the CO2 Foundation. So in addition to founding it, he funds it. Very impressive. In 2019, he wrote a book called Extreme Weather. The second edition is about to be released. I got very interested in, I've read Global Fever earlier and got very interested in extreme weather and contacted the CO2 Foundation, and that's sort of how we got Dr. Calvin here tonight. So Dr. Calvin, thank you so much for joining us, and please, over to you.
I thank you. Some of you may have noticed I'm rather overrepresented in the list of names. That's because I loaned my registration to a number of people in the CO2 Foundation. So they can always change their name if they don't like William Calvin. Let's see if I can get my screen sharing going. Okay. It works. Let me start with just a brief summarization of where we've come from. The first step in climate action was emissions reduction. The year 1980 is about when the predicted global warming and CO2 accumulation was recognized as a fact. Global warming was real, and at a minimum, we needed to stop smoking all those fossil fuels.
Our message out there and showing that, in fact, we are the leading People's Party and the alternative to corporate parties. And after the election, and hit the ground.
Visionary community leaders undertook the difficult task of promoting reductions in annual emissions of fossil fuel. But it was soon recognized that global warming was an inadequate term for our problem, that climate change was better because climate impacts could worsen without explosive increase. We've still got microphone problems. If you could mute everyone's. Okay. But the second step in climate action is upon us now. We now know that for 5 types of extreme weather, something flipped between about 2000 and 2012. And for those 5 types, their annual numbers or intensity more than tripled. However, the CO2 accumulation merely crept up, and the global overheating only changed gradually during that period. That's nonlinearity, a particularly dramatic example. In 2018, the IPC stated that CO2 removal was going to be necessary, in addition to more emissions reduction. CO2 Foundation was created to focus on the extreme weather surges and CO2 removal. And we're now trying to educate civic leaders on emissions reduction about the urgency of expanding the climate action agenda. This talk in particular is going to ask why our climate problem has turned into a climate emergency. And it's largely because of surges to extreme weather in the first decade of the 21st century. That'll be about half the presentation, sort of what's the emergency. Then I will go into the mindset of emergency medicine physicians that we will need to adapt for climate action. The finale will be about urgency, the timescale now needed for a climate fix. And it has to be one that's fast enough to prevent the collapse of civilization. In emergency medicine, the initial focus is not on the root cause of the patient's problem. The initial focus is about knock-on problems of the immediate life threats, such as internal bleeding, shock, arterial bleeds, and so on. Our climate problem has secondary threats as well, and extreme weather is the best example. They may threaten civilization on a much faster timescale than does the underlying overheating. Here is NOAA's compilation of billion-dollar weather and climate disasters. These are the ones for this year. For the first half of the year, there will be more to be added. 10 such events in a year is an all-time record, particularly for only half a year. So what makes climate an emergency now? I mean, emergency is not always hyperbole. The extreme weather of the last 20 years has featured 5 sustained changes where an aspect of extreme weather suddenly became much worse. None of them have flipped back. I mean, these are not just singular big events. They're a record of them. The first one I'm going to cover is severe windstorms. I'll then segue into the inland flood story. And they all come here from this billion-dollar database of events that were so bad that they got into the $1 billion per episode category. Here's the windstorm data. It starts out back in 1980 and goes forward to about 2007, with about 5 such events every 4 years. And then about 2008, something seems to change. The average goes up about 5 times. We are now up to 6 per year, but it's actually about 7 in the last 5 years. Okay. Now it's a similar story. Well, first of all, let me say that windstorm in this case means clusters of tornadoes, other severe vertical convection events like hailstorms, and it includes derechos. Now, on the West Coast, we don't see much in the way of derechos, but east of the Rockies, they're becoming much more common. Here is a 4-day period back in July of '95 when there was a derecho starting out west every day. You see that July 11th in green. July 12th is that really long brown one that started in Montana and wound up in Pennsylvania. July 13th was the short one there. But you'll notice that part of Minnesota has 3 derechos in 3 days. And then the July 14th starts further east. The upper part of Michigan goes all the way to the East Coast. Okay, here's the story for floods. And again, these are big inland floods. This is not coastal flooding. These are the big inland ones that are over $1 billion a piece in present day dollars. These are inflation corrected. They were averaging about 1 every 2 years. After 2010, it went up about 3.6 times. Then we come to fires. Here's the Camp Fire, and that's Paradise, California there. They have become on NOAA's $1 billion plus database. They've become 3.5 times as common as they were before 2000. Here's the plot. There's the data starts about 1985 here. An entirely different system of record keeping existed before '83. So this shows a 3.5 times change in the number of $1 billion. Now, you know, some of them are $10 billion events, but they're still counted as one. Now, what's not shown is the annual count of all wildfires. In other words, without a $1 billion threshold, the count really didn't change. Now let's discuss heat waves. Back in '95, the big Chicago heat wave killed 739 when all the counts were in. And 1,000 or so deaths used to be considered huge back in the 20th century. What changed is they became mega heat waves. We only had 2 of them. This one in 2003 in Europe. The plot here is just showing you the degrees of temperature above the previous year's same week amounts. And then people commented on this saying it's one of those black swan events. We'll never see another one in our lifetime. And so 7 years later, there's the second one. 56,000 dead in Russia. Both of these are serving the course of about a month. Now, the other kind of severity increase is installed hurricanes. What you see is Hurricane Harvey here. It came in ashore in Texas, stalled, backed up to offshore, continued down towards the east, went ashore again. Now, during all of this, Houston was getting hit with both the winds, the storm surge, and the rains, which couldn't drain off because of the storm surge. Houston got 50 inches of rain in 5 days, 4 or 5 days. Their annual rainfall is about 52 inches. So this is a year's worth of rain in less than a week. Okay, those are the 5 types. Not all kinds of extreme weather have changed. For example, here's drought. Sort of a big billion-dollar drought about once every other year. But as you can see, never more than 1. What you see is that at about 2000, it's not fixed really, the average goes up. If you just take the most recent 20 years, the average is up at 0.8 per year. So this isn't even doubling. It doesn't say that some aspects of droughts and hurricanes, for that matter, haven't changed. It's just that the most extreme ones have changed in 5 cases and not in 2 or 3 others. Now, the reason for this is probably, it's not established yet. These things are only beginning to be worked on. But the nature of the jet stream is implicated in most of these. It's not clear about fire weather yet. But in the case of the other 4, it's pretty clear that there's a major player in this. Basically, jet stream starts getting loopy like this. And if you get a big high pressure system like the upper right there, it just doesn't move eastward the way it should. Then the jet stream behind it tends to buckle, and you get these long loops. That allows colder Canadian air to come south, and then you have these blocky high loops, which is warm air going north. Okay. Now, here's another example for you. Stay in place blocking high can create these various types of extreme weather. May not be the only cause, but it's sure a prominent one. So a stay in place high, like the one over the deep south here, because it doesn't advance eastward. Normally these loops are sort of like a snake progressing along the path. They drift east over the course of a week or so across the continent. But if there's blocking high, the jet stream tends to buckle like this. And here you see the jet stream, coming ashore here, up around Seattle, going down to Mexico, and then going due north back to Canada. Just because the high that's parked over the eastern part of the U.S. Now, stay in place low tends to create severe floods. Stay in place high means no clouds to relieve temperature buildup. And that's a common way you get heat waves. Now, it turns out that for the big ones, the megas we've had, they have been preceded by a springtime drought during the growing season. One of the things this means, of course, is that during the summer, the heat evaporates all of the surface water in the ground, which is providing evaporative cooling of a few degrees. And so once that runs out, it warms up a lot more. So those are some of the players where the jet stream turns around, which is quite a big deal. I mean, these are 100-200 mile winds that are reversing direction 180 degrees. You can get stalled hurricanes from these. you can get big windstorms near the turnaround. Okay, here in summary are some years to remember when things changed on us. There's the ramp of overheating started around 1977. About 1984, the curves start diverging for land and sea. And the land temperature more than doubles its rate going up. Global mean temperature is about a third of the way between those two curves. It's a 2-to-1 ratio. Okay, now on top of this, we have those 5 types of extreme weather kicking in. And they're actually clustered in times when temperature isn't changing very fast. This has led some of us to speculate that this is like a change of phase. That's when water evaporates, ice melts and such, where the additional heat put into the system is going to produce something other than temperature change. It's going to change the ice into water, or the water into water vapor. Okay, let's come back to what makes it an emergency. One must survive the short run in order to make the long run relevant. That focus in emergency medicine is what the climate crisis is now requiring of us. Gradual overheating secondary to excess CO2 from emissions is no longer the correct focus for understanding how much risk we now face. For planning, boxing's 1-2 punch may be a more appropriate threat to counter, not just the gradual worsening in overheating. So I'm going to go through now what emergency department physicians sort of have as a mindset of how to get things done in the right order. You can always say there are sensible anticipations, and for winds and heat waves, certainly burying power lines and creating backup for air conditioning. For floods, it's a matter of rebuilding a lot of infrastructure to resist them. And it's certainly going to require us to relocate people out of floodplains and coastlines that are low. Stockpiling, obviously, just in time, I'm afraid, has left us without much stockpiling. But the other thing we need, which we saw with the pandemic, is you need to do economic modeling of how to mitigate emergencies. Planning we should have done before the pandemic and its recession. Certainly for climate's extreme weather, if we're doing much in the way of anticipation, it's not very noticeable. Then comes sort of about the first thing when the patient hits the emergency department. Protect the patient from the usual causes of terminal downhill slides. This is commonly called stabilizing the patient. Public works construction in the 1930s, for example, likely prevented civil disorder in the Great Depression. For both pandemics and climate, this sort of thinking appears not to have been done. Then you come to the more familiar diagnosis and prognosis. For climate, the working diagnosis since about 1980 is a global scale overheating caused by the accumulation of CO2 from emissions of fossil fuels. The diagnosis has been a success, but attacking the root cause, the emissions reduction, is now too slow to do the complete job it needs doing. Prognosis: to evaluate urgency and motivate action. Guess where things seem to be heading? Climate models are good for estimating climate change over the course of a century, but they are only beginning to address the dynamic aspects that can create climate flips within a decade. None of those 5 surges in extreme weather were predicted. A general increase in extreme weather was predicted back in the 1960s. But the flip aspects is not something that science is yet good enough to handle, and certainly the computer models we make to illustrate it are just beginning the last few years. Rule out other problems. This, in fact, is the most time-consuming and repetitive thing. You've got to make sure that your first guesses were right. They might have been wrong, or something new may have come along since, such as internal bleeding. And many of these can be a fast-track disaster. So for this in the climate space, again, only beginning. Formulate a plan of action and explain it to the patient to get consent. For climate, we've done a lot, but it's proving inadequate. Like most diets, emissions reduction has failed. The annual bump up in CO2 from emissions is about 50% greater than it was before 2000. We must now focus on a quick cleanup of CO2, as in using a kidney dialysis machine to quickly clean up an aspirin overdose from circulating blood. Finally, try to prevent a recurrence. So before you discharge the patient, you set about trying, for example, to persuade a patient with asthma to stop smoking. I'm afraid emissions reduction is an exact parallel here. But note that addressing this longer term is the last thing to do on the doctor's medical checklist. Most of the list was concerned with keeping the patient alive to make the long run relevant. Now here I'd rate this as a partial success. We've had 50 years of climate education efforts, but something is preventing effective climate action even by the knowledgeable. The only candidate I have for that is this sort of stay in your seat drama mindset for the surreal, where gunshots on stage don't cause you to hit the floor and phone 911. Now I'd like to talk about just a sketch of the timeline of climate action projects that might actually reverse much of climate change. That involves removing CO2 by one method or another, and there are several dozen methods that have been proposed. There's just been no money to develop them and test them. So here's a plot of a timeline from 1980 to 2050, 35. And I'm plotting on the vertical scale climate impacts. Now, I don't mean by that emissions, or I don't mean CO2 level, I don't mean the warming. I mean, for lack of a better word, the misery index, the climate misery index. And what this shows you is that Without a surge in CO2 or warming, we had a surge in impacts developing between 2000 and 2012. Now, this is likely to continue, and it's likely to hinder the efforts we make to fix it. Now, there's no guarantee that this, of course, is a linear rise. It might pop up again. But at any rate, up is the trend. Now, our desired future via CO2 removal would be climate cooling, the extreme weather becoming less violent. But I'd caution you here that sea level rise will probably keep on rising for much of the rest of the century. We will still have to deal with moving people out of coastal plains, out of a lot of river deltas, and so on. Now, the timeline for drawing down excess CO2, irregardless of the method that we use, I'm trying to show you what it takes to do a really fast, big project. First of all, you need to get the experts and the money for essentially a Manhattan Project 2.0, if you want to call it that. There's a design phase, and just as in the Manhattan Project, where they wound up with two very different prototypes. Then comes some field testing, and eventually, you finally get the consent of governments, you have a mass deployment. The way to do this fast is with a nonprofit foundation with a finance committee of tech billionaires, probably, to do the design and prototyping as quickly as possible. But once you get mass deployment up to the level that you've calculated you need to be at, we have the question of how fast cooling starts. Now, if we're emitting 10 gigatons of carbon per year in fossil fuel emissions, and we're doing about 11 now, I think, you've got to have a sequestration capacity of at least 10 or 11 before you're going to counter that effect. So cooling doesn't start until you're about a quarter of the way up this curve. But emissions still matter. That is to say, if you can haul that 10 down to 8, you may be able to pick up a year. Cooling gets started earlier. So what it takes to haul things down to where they were in 1950 in terms of CO2 is about 40 gigatons a year of scrubbing. That removes a total of 500 gigatons by 1940. Now, I should say that of all the geoengineering proposals we've had, the ones for CO2 removal, not a single one of them comes close to accomplishing countering the 10 gigatons removal. They're down at 1 and 2 gigatons. Even if you implemented all of them, you would scarcely get to beginning cooling. So there is a major job in scaling up that needs to be accomplished by that Manhattan Project 2.0. Now, by 2040, having cleaned up things pretty well, you still got to counter the continuing emissions. They are presumably creeping down, but you have things like methane bubbles, that can pop, putting a lot of CO2 in the air, a lot of methane into the air. And the easiest way to counter its warming effect is to remove additional CO2. don't really have to build a methane removal. You can use some of your minus 30 gigatons per year reserve of sequestration capacity. Okay. So this 20-year project is the fastest that I can imagine. We're doing 500 gigatons of removal. Now, were we to try to take 40 years to finish it, so we'd only be removing stuff half as fast, we would have to remove a total of 700 gigatons. We've got another 20 years of 10 per year. And we would suffer 40 years of extreme weather surges, which means there are wars over resources, there are economic crashes, there are national bankruptcies, all threatening the project. I would like to mention briefly that it's not just CO2 removal that's available to us. The volcanic eruptions have shown us how much cooling can happen if there's a lot of aerosol up in the air reflecting sunlight away from the earth. Now, trying to do this on a global scale is fraught with difficulty. I'm very pessimistic about it, so I wish them luck. But here is an example of a miniature version of it that I think has merit and many fewer problems. If you spread a bright aerosol around, powdered chalk is a good one. You don't have to use sulfuric acid the way volcanoes do. Just powdered chalk suffices to hang around in the air for a couple of years. You have to keep replenishing. But just a simple round trip from the Thule Air Base in Greenland up to the North Pole and back, spreading the chalk all the way. The polar vortex winds will distribute the haze around the halo for you. And you can always have special machinists to do touch-up jobs. The object here, this is going to cool the Earth globally, not by more than 1% of the task. But what it will do is to keep the summer sea ice from melting and thereby having the water warm up considerably to melt more ice and more ice. This ice albedo feedback mechanism for the seasonal ice is a very important player, it is thought, for the extreme weather mechanisms that I've covered earlier. Okay, so this sort of thing we should be considering, because if we undertake a big cleanup, we've got to protect our investment. That's say we've got to keep conditions from getting so bad that the project fails. Okay, in summary, global overheating secondary to excess CO2 from emissions is no longer the only focus for understanding the risk we now face from climate disruption. Because in surges in extreme weather a decade ago, we are already in climate emergency territory where fast tracks disaster must be forestalled. And that's probably a good place to end the talk. Thank you all. So let me stop the share. Okay.
Well, Dr. Calvin, thank you so very much. Very sobering. not enough to get to zero emissions. We actually have to start pulling carbon out of the atmosphere and the other pollutants. A variety of questions have come while you've been talking, and we're okay to take on a few of those?
Sure.
Okay. Is it possible that the escalation of extreme weather that continues to crescendo at this very moment in our neighborhoods, actually, represents a, quote, silver lining catalyst to action, per what you have coined as a neuroscience-informed learning tool?
Well, I hate to take the science very far into this, but we're learning. It's just whether we're learning fast enough. Getting big community action on this, it's going to be hard. We've done, I think, an extraordinary amount in terms of how many climate scientists have taken time to work at educating the public on the subject. We've done quite a lot, but the numbers of the American population that can pass a very simple test of climate mechanisms still hovers down around 40%, which is no better than it was 20, 30 years ago. We assume that our legislators will do better than this. And there have certainly been good efforts made, but it's never resulted in, for example, any money for the geoengineering type projects to even run prototypes and trials. So it's, I think we've oversimplified a lot of the climate change. People talk about it in the same breath with air pollution, but it's not. CO2 stays in the air for 1,000 years. Visible air pollution goes away with the next good rainfall. And there's just nothing like that for CO2. We didn't realize how bad that was until about 10 years ago, when it became pretty obvious that it would take about 1,000 years for natural processes to draw down the CO2 to about 20% excess. We're up, now at about 50% excess. So it's a matter where we've got to do the cleanup job ourselves. We can't really wait. But the problem is, of course, we're getting battered by weather and smoke and such. And we have seen in our recent history some of what climate change does. For example, that 2010 Russian heat wave ruined about 30% of the grain crop. It just got cooked. And as a result, Russia stopped exporting wheat. So the price of bread on the world market went way up. North African countries, which were having their own drought troubles, this Russian heat wave put them into crisis mode. When winter arrived, their own food supplies fell short. They had to try to buy stuff on a world market that had already seen prices go way up. And so one started to get bread riots and then civil wars. And while there are all sorts of reasons why some of the governments ought to have reasonably expected trouble. Uh, what we saw was that these kind of extreme weather events can destabilize governments and cause all manner of international problems, quite aside from things which are more of a world economic crash, which we could get out of it. The U.S. exports an enormous amount of grain to the rest of the world. We might reason that if our grain crop was cut by a third, that Americans would still have enough food to eat, but all the countries that were buying from us would probably devise ways to try to corrupt our government so as to get themselves up to the top of the list. That's the sort of thing that the coming world is starting to look like. It's not to say that there's nothing we can't do about it. It's that we haven't been getting our act together.
Mm-hmm. I don't know whether you saw, but a couple of weeks ago, we had a derecho in the U.S. that in basically one day destroyed 1/3 of the corn crop in Iowa just before it was about to be harvested. Now, it continues, to be sure. Question from Scott Murray. If we retool the country's agriculture for both plants and animals to methods that sequester carbon, is that not a viable solution to remove sufficient carbon, assuming we stop emitting as quickly as reasonably possible?
Well, the problem is, I wouldn't call anything a solution. It only produced a 1% impact. And people keep throwing around that term solution as if it were a real substantial solution. I'm afraid all of the geoengineering proposals are in this same ballpark. They're not big enough in their present form to do very much. And just like emergency department doctors, we really have to look to preventing downhill slides.
Thank you. Question from Serena Lee. I learned in one of my classes that some scientists have considered engineering clouds as well. Is that viable at all? I've also heard of painting all house roofs white.
Well, certainly that's a good strategy. The only trouble with painting white is that it means you have to heat more in the winter time. But certainly for the summer, it's a good idea to use the electric load. Clouds are an interesting problem. It's the biggest uncertainty in all the climate modeling. Some people might say that solar, how bright it burns, is another one of them. But it has a track record that we know in sunspot cycles. Problem with clouds is that our theoretical understanding of them is not anywhere as good as we wish it were. And there are people working hard on the problem. The predictions that you would make about them just often do not show a significant improvement. Basically, clouds are effective because they reflect sunlight back out in space so that it can't warm the earth. This is what snow and ice does as well. And so this extent of reflection is a big player in the heat budget of the earth. that budget's disrupted by the refrigerator gases and the fossil fuel emissions as well. They may not be visible, the CO2, but outgoing radiation from the surface hits the CO2 and absorbs some of the energy, and they then re-radiate infrared in all directions. About half of that is headed back down to Earth. So that's how we get the CO2 warming. But the reflective, the visible wavelength reflections are certainly being looked at. There are versions which called marine cloud brightening that have to do with basically spraying water into the air and through a very fine nozzle, so that it will accelerate the natural tendencies to form a marine cloud layer. And if we take the average cloud cover of the Earth, 27% up to 30%, we might make some impact. But all of these things, other than the CO2 removal itself, are just tweaks. I mean, they don't really fix it. I wouldn't call any of them solutions, because the solution has to take the CO2 out of the air, and it has to do that both to reduce the overheating and the
Yes, we've emitted something like 2.4 trillion tons since the beginning of the Industrial Revolution into the atmosphere. Pretty nasty greenhouse gases. Question from Sharon Holly. Our agricultural practices emit a significant amount of emissions. You mentioned diet earlier in comparison. Are we eating ourselves out of house and home?
Oh, we do have methane from the grazing animals, which sort of have an extra stomach to digest stuff, and that releases CO2 and methane. If there's not much oxygen available, it gets all used up, for example, then the primary production is methane. We could try to re-engineer the food supply, and a lot of the suggestions about cutting way down on the beef consumption would indeed make a lot of sense. If you eat the grain you grow, if you eat it directly as bread and soup and so on, you get I forgot what the number is, but if you feed that same grain to the cows, you get only about 15% of what you got through eating the bread or soup. The chicken are about 25%. Pork is about 20%. But beef is down around 15 or 16.
Doesn't sound very efficient. So, new question. Based on your knowledge of the human brain and nervous system, what is the most effective way to communicate about the climate crisis to both deniers and those who say they, quote, believe in climate change, but resist acting?
Well,
tough question.
Yeah, it is. There is, as they say, there's the problem of, yes, but what can we do? Individual action at the level of consuming less, using electric cars rather than gasoline cars, so on, are all ways where individual action can make some difference, but they're not really solutions. Solutions are things that fix the problem. And that means taking CO2 out of the air, both to reduce its insulation value and to reverse the ocean acidification. When we say that natural processes take 80% out of the air in 1,000 years, most of that job is being done by the ocean absorbing the CO2. That in turn changes the buffering system, and the pH creeps towards acidification. So you've really got to solve both of those problems together to have a very good long-term prospect.
Do you have any thoughts about how we can remove carbon from the oceans?
Yeah, I've pursued that somewhat, mostly as just trying to develop a simple sketch of the possibilities out there. Doing it fully accounting, for all of the organic carbon cycle within the ocean is a job for real pros. And again, that's Manhattan Project level sort of thing that needs doing. But yes, the oceans are 70% of the Earth's surface. Anything we do on land is going to compete for both agricultural land, compete for fresh water, for transportation fuels, all of those things. And if you simply do the sequestration job in the ocean, you can probably avoid most of those conflicts. So there's some very real reasons why we have to take a hard look at doing it in the oceans. I think we have fairly little time in which to do that. I'd like to see a lot more projects being undertaken to get the bugs out of whatever ideas we come up with.
Sounds like you were really a fan of a Manhattan Project, or perhaps a World War II level, let's really go at this in a big way. Do you have any thoughts about how, or what are your thoughts about how we would go about getting such a project launched?
Well, my best shot at that so far has been to say, it's just like that slide of mine showing the design phase, the prototype phase, and so on. It's hard to persuade legislators to buy onto something unless they know that it's stands a good chance of working. And that's why I think we need, say, a non-profit organization doing the design and prototyping and testing, so that after 3 years or so of that, you could actually go to the legislatures of the world and ask them to start their own implementation projects. This isn't just a US thing, though. Since we're the biggest contributor to the CO2 accumulation, it would be right for us to lead the effort.
That certainly makes sense. It sounds like you don't think we should really be approaching politicians about solutions to the removal problem anytime soon. We should be looking for some other funding sources to.
Well, other funding sources certainly, but I wouldn't delay at all in trying to get them. Just as long as it's not oversimplified. That is to say, we have to keep in mind that prototypes don't always work. There's going to be a much more. There's going to be years and years of development to get something that works well. So I wouldn't anticipate that even when we start deploying in 2025, that would just be Mark 1 of a sequestration mechanism, and that we would continue adding sequestration capacity with improving versions of that. Now, I would like to be able to reassure people that we could know the science well enough to keep ourselves out of trouble in going about this. But while we have had in this country a great deal of funding for things like medical research, if I look at the state of the science within, say, the earth sciences in general, they haven't had that kind of infusion. And when I look at sort of how many things are being undiscovered that we could have answered 50 years ago, if we'd had the money to go about it, then it's really, I have to assume that our CO2 sequestration thing is going to run into various things in the ocean's organic carbon cycle in particular, where we're going to have to change our plans as we go.
Nancy and Derek Cassidy ask this: what about seaweed farms and capturing CO2 from tree planting and soil restoration?
Well, to the extent that involves the ocean, I rather like the idea. You've got to remember that things done on land can burn down, and that diverting enough water to put sprinklers all through the forest is probably not practical.
For sure. How much time do you think we have to really reverse the climate mess that we've created? You know, to stop the bleeding in the emergency room, if you will.
Well, that's anyone's guess. I mean, there's not a scientific answer to that. It's a, I did my estimate of, let's clean this up by 2040. I did that not from the standpoint that I thought we had 20 years to spare, but because that was the fastest method I could imagine. If you have seen anything of how long projects, big building projects, for example, to be planned, to get started, to have to take time out to redo something, there's all sorts of things like that. And architects and city planners and so on have a lot of experience with this. And I've only absorbed it a bit as a consumer of their PDF files. But I do know, I think, how they think about it. And that's what I've tried to infuse into the Manhattan Project.
Mm-hmm.
My notion of how to go about the project, I might add, is, first of all, I just don't think you get money out of government fast enough to do the design job it needs doing. But I think if you had a dozen tech billionaires this year as your finance committee. And this was a nonprofit that they were not getting anything back from, but they were also getting tax donation credits for. I think we could finance the first 4 or 5 years of the thing that way. And I think that's necessary to get a product that you can then sell to the legislatures of the world.
Makes sense. I was thinking earlier this afternoon about, this is a question that I came up with. To address the climate issue, we have environmental considerations, health, scientific, economic impacts, social impacts, legal, political, even humanities are involved. And all of these, in some sense, have to be integrated to come to a final solution that's both reducing emissions and removing the, going through the drawdown process. When I was thinking about academia, one of my mentors from the past, Buckminster Fuller, used to like to say, nature doesn't have a department of biology and it doesn't have a department of chemistry and so forth. And yet universities are organized along those lines. So what should academia be doing to, what can they be doing to address a holistic solution to the climate catastrophe that we have going?
Well, I think they've been the leaders in much of it so far. I think I've seen major programs like we have a new College of the Environment at the University of Washington, and I've seen a lot of its growth. It does not include some departments like biology as departments. It includes individuals from the departments. But basically atmospheric sciences, oceanography, geophysics. I mean, a number of departments like that form the core of it, along with fisheries. So there are reorganizations like this, and the ones for environmental problems are really the best examples.
Mm-hmm.
I do like the prospects, but we ad hoc arrangements where you identify part of the problem and go out and find people to come and talk about it and do a little planning and write grants and so on. That's going on all the time. And I like what I've seen. What we haven't had, there's a whole sort of almost a moral aspect, imperative to act, to protect not just our grandchildren's lives, our children's lives, it's now ours, but it's there are issues around whether we should speak too. If we speak too forthrightly, we're likely to scare people, and if we don't speak forthrightly, they won't move in time. Okay, I'm
Okay.
sure
Fair enough.
that made that call, and I think the balance on that is going to have to change. We really are with the extreme weather surges, we're getting into difficult territory where we could see our means of meeting the problem.
Yeah. Well, I think I mentioned earlier, we had a few days ago, September 4th, I put together a presentation about climate, and I looked up the fact that California had 1.8 million acres burned so far this year. And now 5 days later, we're up to certainly over 2.5 million, approaching 3 million acres, our all-time record. So we get it. What you're saying is clearly true. Let me ask one final question, if I might. And that is, you've got an audience today that are all, in one way or another, I think we could call ourselves climate activists. What would you like to see from us?
Well, I'll take note of the people who have undertaken to do the first step of emissions reduction are the natural leaders for doing the second step of actually doing the cleanup and all the relocation that it's going to take in the next, the sea level rise estimates are such that by 2050, we will have a lot of trouble. Low-lying coastal plains, the Mekong Delta, is likely to be underwater at high tide by then. The same problem would exist with Bangladesh. We will start seeing many places like this getting into great humanitarian crises.
Miami.
So, I mean, it's we need the leadership now, because I do believe we're quite capable of handling this. It's just we're going to reverse all the damage that's been done, because the sea level rise and the glaciers continuing to skid downhill will continue for the rest of the century. And so we're going to have to handle those, but actually getting things to cool, to get the extreme weather to retreat, those things I think we can do. And I'm anxious to see us get our act in gear in that direction.
Fantastic. Well, Dr. Calvin, Marion, are you with us? Where's Marion?
I'm right here.
Could you join us?
I'm here.
Thank you. And Dr. Calvin, on behalf of the North County Climate Change Alliance, we really want to thank you so much for your time tonight and the effort you put into working on our global crisis. And as a small thank you for joining us tonight, we at the North County Climate Alliance have purchased a tree in your behalf, and we will mail a certificate to you commemorating your tree and your wonderful contribution to our problems, our effort, and to our evening tonight. Thank you.
Thank you.
And Meryl, do you want to close out?
Thank you, everybody, for joining us tonight. Thank you, Joe, for moderating. And thank you very much, Dr. Calvin. We appreciate you being here and sharing all of your great ideas with us.
Okay, thank you.
All right.
Thank you.
Good night, everybody.
Good night.
Night.